Welcome to the review for Unit 15 on geometry and transformations. So number one is, first of all, it's a line. And the second thing you need to know about that line is that we could call that line AR, or we could call it line RA. Number two is a line segment, and line segments are named by their endpoints. So that is line segment CM or line segment MC. Even if I have an X there, you would have to call it CM because it's always named by its endpoints. If I put an X on, say, the line, I could have 6 different names with any 2 letters on the line. Last thing is called a ray, and there's only one possible name for this, and it is ray VH, even though this arrow and this arrow are the same. In this instance, that is not always the case. The symbol always points to the right. The ray could point anywhere. Angles are measured by something called a protractor. They have 2 rows. In this row, you start at 0, and this is looking like a little actually less than 30. It's looking like 29 degrees, although it could be, I could have meant 30 there. And this one on this side is one less than 85, it's 84 degrees. And notice these arc marks show us which side of the protractor we are using. Both of those angles were less than 90 degrees. So the first angle here is, we're going to call angle KPX. Could have called it angle XPK. The key is that P has to be in the middle because P is the corner of the vertex. Then we call this angle over there, we can call that one XPR or RPX as long as P is in the middle. And there's one more angle here, it's the 90-degree angle. That's angle KPR. And notice this angle symbol does not tell you the size of the regular angle. So KPR with P in the middle, or RPK. Draw any angle between 91 and 179 degrees. In other words, an obtuse angle. So an obtuse angle, right, has to be open more than 90. So here's an easy way to do it. That's a 90-degree angle, right? So it has to be more than that, more open than that. So anything like that is an obtuse angle, or between 91 and 179 degrees. So it says label it ABC. So you have to put a point A here, then you have to put a point B as the vertex, and then you have to put a C over there. As long as B is the vertex, you'll be fine. Find the measure of angle DJZ. Now DJZ is this side, right? Because DJZ, and so that is using, right, we're less than 90 degrees, so I'm going to say that's 73 degrees there. And that's this one right there. And I already did it for myself, and I said 73 degrees. Find the measure of DJT, that's the other side, and the other side, so these better add up to 180, right? So I could do it through subtraction, but let's also be, so this one better be 107 degrees. Let's see, right? There's 100, and then there's 105 right next to it. It's 107 degrees. The two, they're a linear pair. They are supplementary along, and they're adjacent along a straight line. That means they're a linear pair. They're supplementary. They add up 180 degrees. Right. The name of the angle shown is angle TPR or angle RPT. Which angles are adjacent to A? Adjacent to A are B and D. Adjacent angles always share a common side. So A is adjacent to B, A is adjacent to D. B and D are not adjacent to each other, but to answer this question, it's B and D. Which angle is vertical to A? That is angle C. Back to back is called vertical. They don't share a common side. They share a common vertex in this case. If A is 72, what are the rest of the angles? Well, if vertical angle is always congruent, the same, and the other ones are supplementary and a linear pair, and there's the 108 again, and they are B and D are vertical to each other. The measure, right, this little m here means the measure of. The measure of angle MCN, that's this one here, is 74 degrees. Find the measure of angle LCN. All right, so because there's two possibilities. It's either the same or it's supplementary. In this case, it's supplementary. And so we're going to get 106 degrees. Our angles M and CN and LCN, the two we just found, a linear pair? And the answer is yes, right? Because they're they're a pair along a straight line, right? We verified that they add up to 180 degrees. They're adjacent along a straight line. They share a common side, CN. And so, yes, they satisfy all the requirements. What is the measure of an angle supplementary to the given angle? All you have to do is subtract it from 180, and it's 174 degrees. And they do not have to be next to each other to be supplementary. Are the angles complementary? Does a 48 angle plus a 32 add up to 90? Did I say supplementary? Are the angles complementary? No, they have to add up to 90 to be complementary. Right? So these are a linear pair, right? They're along a straight line, adjacent angles along a straight line, and so they have to add up the 2x and the 132 to 180. There's a nice easy two-step equation to solve. 2x equals 8, and 2x equals 48, yes, and then x equals 24. Right, those are complementary angles that add up to 90. Now, they don't have to be next to each other to be complementary, but there's an angle that's 4x and an angle 18, and they have to add up to this 90-degree angle. So we're subtracting 18 from both sides. 4x, we're borrowing. 4x equals 72, divide by 4. 4 goes into 7 once. 4 goes into 32, 8. And so x is 18. All right, find x. So now this is taking things together. So this is called an exterior angle. And we're going to use two things we know. All right, so if that's an exterior angle, this is a linear pair with that, and so it must be 30 because they have to add up to 180. We know the three angles in a triangle, the interior angles, always add up to 180. So we have an x, we have a 90, we have the 30 that we just found for y. They have to add up to 180. 90 plus 30 is 120. I'm just going to take a little shortcut and subtract 120 from both sides, and x has to be 60 degrees. Which angles are congruent to B? Now these mean this is a transversal. That is a line, transversal. That is a line, in this case a line segment, that is crossing two other lines, in this case line segments, but it's the same thing. And in this case the transversal is crossing parallel lines. When a transversal is crossing parallel lines or cutting parallel lines, we say, there are patterns. All right, so B is congruent to D because D is vertical to it. You have to know the reasons as well. B is congruent to F because F is corresponding. That's the math word for matching. It's in the same spot. So it's in the corresponding spot. And then what else? H. H is the same measure as B. And the reason is because it is vertical to F, and F is corresponding. Or you could have done it's corresponding to D, and D is vertical. Either one is proof that it is congruent to B. If B is 116, what is the measure of angle E? Well, B corresponds to F, so E is its linear pair, right? once you move it over there to its corresponding location, and so it's got to be 64 degrees. All right, so what kind of triangle is that? There's a 90-degree angle. If it has a 90-degree angle, that's called a right angle, and this is called a right triangle. They're all less than 90. That means it's acute. Find the measure of the missing angle. All right, so we have x plus 35 plus 71. The three angles always add up to the same 180. 71 plus 35 is 106, so x plus 106 equals 180. Subtract 106 from both sides, and we have to borrow 4. I'm getting 74 degrees for x. By the way, if there was one angle more than 90 above, it would be the one that's obtuse. All right, so complete the congruent statement. So we have triangle GPK is congruent to. So that's how you read that, is congruent to. And that means it's the exact same size and shape, just spun around or flipped over. And so we have to match. So we're going to play a little matching game. G matches Z. So we're going to put Z first, and then P. I know the next one popped up. P matches T, and K matches H. If triangle, so now for a different triangle down here, if triangle ADF is congruent to MSU, then angle A must be congruent to angle M. We don't know the measurement, but we know they're the same. Side DF must be congruent to side SU or line segment SU. And yes, you could write US, but why would you? And side FA, right, FA must be congruent to UM. The order totally matters in your congruence statements. These are all different congruence statements. So then we translate it. So we're translating S to U 4 units right. So if you go 4 units right, you add to X. 5 units down, you subtract from Y. So this one should, S prime, right? The image should be a prime, should end up at 0, -3. Let's see that. So S is at -4, 2, and we're going to end up going 4 units right. 1, 2, 3, 4, and 5 units down. 1, 2, 3, 4, 5, 0, -3. We're there. That's S prime. Okay, T should be at 2 and 0. So T, we're going 4 units right, 1, 2, 3, 4, and 5 units down, 1, 2, 3, 4, 5, yes, and there's T prime, and you write, it's the same exact triangle, so U prime has to be there. I'm going to clean that up a little bit, put T prime in its spot, and U prime, I could either, whoops, I forgot to write T prime here, and then U prime, right, add 4, you ended up at 3, and subtract 5 at 3, -3. Is that where U prime ended up? Yes, it is. That's a translation. Now we're going to reflect V across the y-axis. Please always read this, right? I could flip it up there and have it land right on top of each other. Unlikely, but it could be that. Determine the new coordinates. All right, so now we're going to flip this across the y-axis, so it has to be exactly the same distance away from the y-axis, so that's there. This is at -4, so we're going to +4, and there's the mirror image, V prime. Now when you flip across the y-axis, the x-coordinate becomes its opposite. And you could see that from the picture, or you could just know that either way, right? -1, -7 is now a +1, -7. Reflection. So reflections and translations are types of transformations. Which angle is vertical to EBD? Well, there's EBD. The angle that's vertical is angle ABC, or CBA, but B has to be in the middle. If angle EBD is 151 degrees, find the measure of ABC. Well, ABC's vertical, so it's the same, 151 degrees. Are angles EBD and ABC a linear pair? No! Linear pairs are adjacent angles along a straight line, not vertical angles. Find the measure of x. Okay, well, now this one's a little tricky, right? I'm going to move 112 to its corresponding location. If that's 112, that's 112. Now this one is different, right? 4x plus 8 equals 112. They don't add up to 180. They're vertical. Be careful of that. Yeah, I'm not sure we did one of those in class. 4x, and we got to borrow here. That's a 0, and that's a 4, and that's a 0. 4x equals 104. Divide both sides by 4. 4 goes into 104. 4 goes into 10 twice. Whoops. 4 times 2 is 8. Remainder 2. 4 and 24 is 6. X is 26 here. All right, so you're so used to adding things up to 180, this one would be a stumper on the test for many people. They're vertical. They're equal to each other. Define each transformation as either a translation, reflection, or combination. All right, so let's see what we got. M to P. So M to P, right? It's not flipped over, so it's a translation. Let's see what kind of translation it is. And here I'm going from 3 down to -7. So 3 down to -7, you could count it, but it's 10 units down. And so if that one's 10 units down, all the others are 10 units down. You really only have to check one because they're all going to be moved the same amount. Otherwise, the shape will not be congruent. P to O is clearly a reflection, but you should always say what you're reflecting across. Reflection across the y-axis. Right? We flipped it like a pancake over the y-axis. M to O. So M to O is literally a combination of the above. Right? I made this one very easy. Right? I translated M to P, and then P to O. Now on the test you will rewrite it out, but that is what it is. It's a combination of the two above. Now, I didn't use N here because N is something called rotation, and we will talk about rotation another time. Take care. Do your homework before the test.